So welcome back, everybody. I see everyone is coming back from the coffee break, which I hope you enjoyed. It was very kindly sponsored by Inobo. We're very grateful for the sponsorship, and to all our sponsors, thank you so much for the support. So welcome back. We're now turning to panel 4, which is on NPP project management optimization, recent achievements, and future AI advancements. This session focuses on how artificial intelligence can transform project management for nuclear power plants, from planning and scheduling to cost control and risk mitigation. So we're very much going to be in the construction space, in the major refurbishment space. We'll be hearing about recent successes and explore what's next for AI-driven optimization. Our keynote speaker for this session is Dr. Evgeny Burnaev, Director of the AI Center at the Skoltech Institute of Science and Technology in Russia. Evgeny Burnaev is Vice President for AI Development and Professor at Skoltech, where he also directs the Skoltech AI Center. His research focuses on engineering, AI, generative modeling, and physics-informed machine learning. Professor Burnaev leads industrial projects in energy, transport, and climate modeling. His achievements have been recognized with the Russian Government Prize in Science and Technology and inclusion in the Elsevier Stanford Top 2% Scientists list, among others. Dr. Burnaev will be joining us very shortly, I understand. Oh, here you are. Thank you. Sorry, I was expecting you from my other side. Welcome to the stage. Please join me in welcoming Professor Burnaev. Thank you.
Okay, so thank you very much for inviting me to this wonderful event. Very interesting for me because initially I worked mainly with other industries, not with nuclear industry. So let me comment a little bit how we can use AI in complex engineering processes, in particular for nuclear power plant construction, management, and optimization. Actually, until recently, usually we use AI to solve quite narrow tasks. We construct narrow AI predictive models. For example, if we consider, say, production of some metallic pipes, we can use CCTV camera to detect defects on a working piece, on a rolling mill, by analyzing signals from these CCTV cameras using an AI program. However, this is a very particular step in this industrial process. And using this approach, it is very deterministic in some sense. We cannot automate more complex processes of planning, optimization. For example, let me give an example of such process. We all of us know that for construction of nuclear power plants, schedule update is very important, right? It means that we should collect information from working groups, from various KI systems, from technical requirements documents. Then we perform construction of overall schedule, of partial schedules like supply chain schedule, construction schedule. We should adjust them. But if something changes, for example, in parameters of the equipment or in characteristics of business process, then we should recalculate the whole schedule. But using the current approach, it's not possible to do it end-to-end. It means that we should repeat the whole process from scratch. Each step we may use some automation based on narrow machine learning model, but on general scale, we cannot do it. We cannot recalculate it in U. And so nowadays, it's possible to use more powerful approaches. I'm talking about generative models, multi-agent systems. With generative models, namely large language models and visual language models, it's possible to process different types of documents, such as tables, technical drawings, templates, schemes, Actually, for example, we already demonstrated in other industry, I mean oil and gas industry, that it's possible to efficiently use visual language models to validate technical drawings. That is, a language model, it analyzes which specific part of the technical drawing contradicts some specific technical requirements, and it indicates for an engineer that in this specific place you should do some corrections. Another example from the same industry, oil and gas, I mean, that there are a lot of technical requirements for the construction site. They are quite complicated, written in a quite bureaucratic language. For a particular construction site, you should find the place in this big document where a particular technical requirement is located. And we demonstrated that using a system of language models, we can detect a specific place in that document, given a user an engineering question. Then we extract this particular requirement and disassemble it into pieces, that is object 1, object 2, relation between objects. For example, like a pipe should be located not closer than 3 meters to a wall. So object 1 is pipe, object 2 is a wall, relation is not closer than 3 meters. And this requirement represented as, in such machine-readable format. First of all, it can be easily analyzed by a system and provide a correct answer to the engineer. And also, this information then can be provided to the next step, to some other software program that, for example, optimizes the location of different pieces of equipment on the construction site. In this way, you can support the process to be more end-to-end, right? And so this is exactly the capability of multi-agent systems. With a language model, you can write code. You can equip a language model with a memory that can collect some information about your engineering process step by step. Language model has ability to reason and to plan. Because of that, in some sense, with additional, of course, developments, the language model becomes an AI agent that can reason, that can plan, and then can perform some actions in IT system. So you can organize a system of AI agents. One of them will be an orchestrator that divide the whole problem into steps. And other agents, they perform different steps in this process to solve the whole problem and provide the solution to the user. Nowadays, it's already possible to automate and automate engineering processes in this way. I really believe that in quite near future, maybe in around 3-5 years, many of industrial processes, engineering processes, but not only. So many of organizations, including not only industries or production facilities, but also banks, offices, will be more autonomous, will become more autonomous organizations. And complex engineering processes in supply chain, energy, and other complex domains will really benefit from such a combination of multi-agent systems with hybrid models and generative models. And this, of course, is very important for engineers, because now engineering systems become more and more complex. Engineers spend a lot of time for quite, typical job. Typical, I mean that not very intelligent. It's better to allocate your precious time for really designing the system itself, but not for optimizing its parts. So, as I said, in the medium range, in 5 years, this is already possible to do. And we know how to do that. There exist appropriate information security frameworks and IT frameworks to construct multi-agent systems already. So this will support verification of results and trustworthiness. Of course, we will need an AI platform for that and ecosystem of applications, but this is possible to develop, as I said, in 5 years or so. So this is my vision. Thank you very much. That's it.
Thank you so much, Dr. Burnaev, for opening this panel for us and for your insights into some of the concrete ways that AI can and is already being used in NPP project management, and also what will be possible in the future. And hopefully we'll be expanding on some of these concepts as we move into the panel discussion. So to introduce our first panelist, joining us on the stage, Dmitry Fomichev is Head of IT and Digital Programs at Rosatom. As Director of Engineering Simulation Software Development at Rosatom, he focuses on the development and practical application of mathematical modeling systems and AI technologies for analyzing physical processes occurring in industrial facilities. He coordinates the working group under the Russian Ministry of Industry and Trade on the development and engineering software. Dr. Fomichev. Our next panelist is Mr. Kan Shuo, who is the Deputy Director of the Project Management Department at China National Nuclear Corporation, CNPE. Working for CNPE for more than 10 years as planner and project manager of equipment procurement, Mr. Kan Shuo is now responsible for NPP's construction, digital transformation, and study methods of project schedule control. As the director of CNPE's Smart Construction Site Platform Systems deployment and integrating the business system with a Smart Construction Site Platform, he solves the project management construction cases through his work. Mr. Kan Shuo, welcome to the stage. Our next panelist, Mr. Ahmet Tokpınar, is Principal Vice President and General Manager for Nuclear at Bechtel, where he oversees global nuclear power projects and strategy within the company's Nuclear, Security, and Environmental Business Unit. With over 30 years of experience, Ahmet has led Bechtel's engagement in major projects, including the Voros Units 3 and 4 completion, Poland's first nuclear power plant, and the Natrium Advanced Reactor demonstration. He holds degrees in civil engineering from Bosphorus University, construction engineering and management from Rutgers University, and an MBA from Johns Hopkins. Ahmet Tokpınar. And joining us as well is Mr. Dev Amratia, who's a chartered engineer and co-founder and CEO at nPlan in the UK. nPlan is a machine learning company that predicts construction project outcomes using one of the world's largest data sets of completed schedules. With 9 years' experience delivering energy sector projects across 3 continents, he later contributed to the UK government's National AI Review, published in 2017. Dev is committed to improving project delivery through data-driven decision-making. Dev Amratia. So I think you'll have seen through the biographical introductions that each of our panelists brings valuable experience in managing complex nuclear projects and integrating advanced technologies. So let's jump right into the discussion. Welcome to panel 4, gentlemen. Thank you for joining me. So we've heard how AI is already being applied broadly in nuclear operations and across nuclear power programs. That was really the focus of panel 3. But large capital engineering project management presents some of the most complex challenges in the sector. I think we can agree on that. So the effective control of commercial risk, for example, project schedules, costs, these will remain directly linked to both NPP life extension and new capacity deployment as well. So we'll explore how AI can help optimize planning, scheduling, cost control, and risk mitigation for these nuclear power projects. So let's start by looking at what's working now, if we can, some of the recent achievements, and I think you're eager to share some of those with us. And then we'll move forward towards sort of what's happening next and how we can scale some of these innovations. Shall we start at the other end? Dev, can I start with you and put you on the spot? Yes? Great.
Certainly. I want to start rather than starting with the solution and how it's changing the world, I want to start with a quick diagnosis of the problem. We're talking about project management here. Nuclear power stations, as I'm sure everyone in this audience very well knows, are complex endeavors. They're not simple things to build. They never will suddenly become simple, irrespective of the promise of SMRs. These are just complex endeavors. And we, as professionals that attempt the act of delivering capital in an economically viable way, have this one struggle, which is the thing that is inside our heads, our brains. Our brains are limited in three things. One, they're limited in what they know, availability. I only know what I know, you only know what you know, we collectively only know what we know, assuming we have perfect communication, which is rare. Two, we are incredibly optimistic about what we are capable of doing. I used to be a project manager in my past life. I used to think my project would be the next best project that my organization delivered. Statistically, that's quite hard. Also, 95% of humanity believes it is not affected by optimism bias. And the third is my favorite, salience. Salience is the ability for the human brain to ignore what it thinks is irrelevant information. And when you manage projects, you will therefore ignore what you think is not important. As an example, I'm an engineer and I used to work on a construction site. I used to love thinking about the big crane that would move a 10,000-ton module onto site. It was just fun, and I just enjoyed doing it. What was I not thinking about, therefore? I was not thinking about this permit, I was not thinking about the documentation, about the certificates, about all of the different paperwork I had to do in order to successfully deliver the project. What went wrong on the project? All of the things I was not thinking about. You take these three things together, and you end up in this situation where the complexity of the projects we need to deliver far surpass the ability of our brains to understand its complexity, and so therefore, we need help. The evidence is clearly there if you look at the really poor and abysmal rate at which we deliver projects on time and on budget. 98% of capital that is delivered in any sector, including the nuclear sector, does not meet the business case that it was already set out to do. We always overrun in time, always overrun in cost. And my diagnosis is because of these three things. So, to AI, because this is a panel on AI, of course. My strong belief and the path I've embarked on with the company I run is that AI that learns from these previous projects, learns how hundreds of thousands of projects perform, and then uses that knowledge to share it with projects that are going through those three challenges that our brain has inside it, open up a whole new world of high-quality decision-making. And that's the magic, well, I'm not going to call it a silver bullet, because nothing is a silver bullet, but it is a key unlock. And of course, over the panel, I'll give specific examples of exactly how and where this applies and the risks that come with it. But the opening that I want to start with is, of course, we have a big problem on our hands. We've tried for decades to solve it through all sorts of initiatives. And finally, there is a piece of technology that is mature enough today to be able to help us overcome the biases that we hold inside our brains.
Great, thank you for that, I think, very powerful kickoff to our conversation. And Ahmed, would you like to build on this and share with us some of your thoughts? We can hear you.
It's working?
Yes. It's working.
Good.
Thank you.
So I totally agree with Dev. I want to emphasize, the complexity on a nuclear construction. This is a business we've been in since its inception. Over 70 years, we built first in India, US, Canada, Spain, Taiwan. Now we're in Poland. We're working with different technologies. And, years ago we recognized, there has to be a better way of doing this because, otherwise nuclear industry is always going to be struggling with cost overruns and schedule delays. So the first thing that we've done, and it's up and running today, is digitize the entire integrated engineering, procurement, construction, startup process. So we have created this, what we call the digital platform. And these are not scanned documents, these are all data-centric. So we create a common data environment that has the attributes from engineering, from procurement, from construction, equipment, and then we have our own, some in-house, some commercial applications in each of these functions that directly integrate with this common data environment. And this common data environment is not just Bechtel's construction, it's integrated with the reactor vendor's design in a 4D model with all the attributes. So right now we have a tool that works seamlessly at all facets because everything is integrated and it's getting its information from this common data environment. So we can see the changes real time. So this is without AI.
I think you need to speak closer to the microphone for our
okay,
online
sorry about it. So,
thank you.
So we're already realizing significant benefits on our non-nuclear projects, you know, LNG replications, because we're paperless. There's no paper that the field superintendent, field engineer is carrying at the site. They have tablets. They can look up, see where the material is, you know, whether the hold points needed, the quality person is at the site getting ready. It helps tremendously with planning the work and executing the work, especially on a nuclear job with NQA1 requirements. Paperwork is a big burden. And when you digitize all of that, you have significant savings. So that becomes the backbone of our AI strategy. Now, how do we introduce now AI into these applications to further improve the decision making? And, you know, we have some pilots that we can talk about maybe at the next question. But that would be the implementing the pilots and then scaling up for broader use within the company on all projects.
Okay, great, thank you. So again, still talking about not replacing decision making, but supporting it and helping it and optimizing it. So thank you for that. Mr. Control, can we turn to you?
Yes, I think the AI is important technology to use in the NPP's construction, and more increasingly. But now they are mainly used for applications for safety measurement and quality control. So I have two examples for you. And first is about we developed tools based AI technology and to analyze the truck drivers' unsafe driving behavior, such as the fatigue driving and others, and some using cell phone when he's driving. And it helps us reduce the violation and the traffic accident at construction site 50%. And then the second one is about we are developing tools to qualify the weld, to qualify the piping weld, and we are expect to get 3 to 5 times work efficiency improvement, and maybe the accuracy rate will be up to 90%. So it is about quality control and safety management. Mm-hmm. So it's indirectly benefit for the schedule control and cost control. Mm-hmm. You know, the better quality control will be fewer repeat, will be fewer rework. So I think it's now is the level.
Okay, thank you so much. So Dimitri, what's working now?
So first of all, Lisa, dear colleagues, gentlemen, let me express my very great gratitude to be here. I'm very honored to be here on this voice of IAEA. AI can become a keynotes have to overcome changes linked to project commercial. AI can become a key tool for overcoming risks in nuclear projects, providing predictive analysis and optimizing schedules and so on in the three more key areas. Well, first of all, AI can analyze vast amounts of information, such as predictive analytics, logistics, costs of some schedules and facilities to create accurate forecasting models, providing and identify bottlenecks and potential delays before they occur. So this is some forecasting software or application. Second one, the machine learning-based technologies, such like this. Predictive analysis enable a shift from reactive to proactive risk management, for example, by forecasting supply chain disruptions. And yesterday, quite more things we discussed about supply chain, And third one, AI algorithms can optimize resource planning and scheduling in real time when we management quite complex NPP projects, maintenance, and so on. But in Rosatom, we, as a part of our digital transformation, of course, we apply all aspects of AI in our management. And we are actively developing such systems for managing mega projects for NPP development, construction, and R&D as well, aiming to significant reduction in schedule, supply chains as well, and budget variability. This is a direct linked to increasing the investment risks in nuclear power. So I think it's a very grateful application and assistant for management and as well as for scientists and engineers.
Okay, thank you, and thank you for showing those links also between the other parts of the program. And we heard about safety and quality, and we'll hear about supply chain. So really, all the different areas. Thank you, Dimitri. Yes, can we turn back to you, please? And
well, you know what?
I don't.
The very first speaker mentioned a very important peculiarity of a human. Any human like something tasty, something interesting. And for engineer or manager, it's very interesting to solve complex problems, not just do standard things. And but all this tedious paperwork, standard steps, actually is a cornerstone of when you manage a complex system, right? A complex construction site. And without that, but humans are not machines. And only by pairing with such assistants, we really can overcome the complexity of managing NPPs. Here is an example. With some big company, we have a big contract, so it's many pages. It's a framework agreement with many partial technical support descriptions. So say around 200 pages, and usually it takes around maybe not less than 10, sometimes 15 iterations to find all inaccuracies, to find all not correctly corresponding parts of the requirements in different parts of this text. And we did actually the following A/B test. we do signing of this of such agreement as is, and we did signing of this agreement using automatic checking by a multi-agent system based on language models. So it took around maybe 3 iterations or so. Another example is, actually this is an example from Rosatom. I discussed with one of IT directors of Rosatom that, okay, they have a lot of subcontractors, and they should generate a lot of technical support descriptions for these subcontractors. And automation of this, it reduces the overall time, maybe like 3 times or more overall time for this. And this is a very huge amount of work to do all these documents. So even these automation and all these processes can be made end to end, should make the process not only kind of not only resource efficient, but also it should reduce the number of delays and various errors.
Thank you. And I really like what you said, that humans are not machines. And I think what we're also hearing is that machines are not humans. And
that's true.
This is
Exactly.
the counterpart, right? Yeah. So thank you, everyone, for kicking us off in this space. And I think what we've been hearing a lot is just about pace and demand and the need for this energy to continue to supply the data centers. That was our kickoff yesterday. And so if we look at the current status of where we are, I'd like to ask you what role you think AI might have to overcome some of the challenges that are linked to project commercial risk management. Because really, we need to manage this risk. We need to be able to deliver to really meet the demands that we've been talking about. So would anyone like to jump in and talk about how we might be able to overcome? And you've been talking a little bit about it, but let's expand and go a little bit deeper. I see you nodding, Dev. Do you want to?
Yeah, you mentioned commercial risk management, so I'll focus on that first. One of the many, but systemically large problems we face in this industry is the topic of strategic misrepresentation. This means we, not just the nuclear sector, but many sectors, expect and incentivize our supply chains to give us good news. What that means is we tend to award contracts on the basis of the lowest price first, right? That's typically the norm, I would say, globally. And if you are bidding, if you are in the supply chain going up ultimately to the financier of the project, you are incentivized to strategically misrepresent the most probable outcome. That means you will say, in simple language, don't worry, of course it'll be done in 8 years for $10 billion, even though you know inside you there is a very low probability that that can actually be achieved, statistically speaking. So what is happening here is a challenge in the management of projects where it is very hard, near impossible, to actually understand how much risk you are taking as you embark on these incredible ventures of multi-billions of dollars over multiple years. And this inability to understand the risk leads to either a failure to make a decision, which is bad in many ways, but more likely you'll end up with signing a contract to which there will be a failure in delivery where multiple parties are failing, and ultimately it shines a negative light. So the opportunity AI has to play here is the impartial body. We've said AI is not a human and humans are not AI, right? AI doesn't care about the politics we're going through. It doesn't try to make you happy or sad. It will use data on previous projects to say, here's what I've seen happen. I'm assessing your bid and your viability, economic viability to execute on cost and schedule for this project, and I believe this is what might happen to you. By the way, you might not like the news you have just seen, but it is trustworthy, it is data-driven, it is not going to strategically misrepresent your outcome, and you can take effective decision quality off the back of it. We've seen examples in the UK of nuclear plants using this to attract investment. The big example in the UK at the moment is Sizewell C, right? But there's a fleet of SMRs coming on stream where if you are the investor looking down onto this project opportunity, you know the strategic misrepresentation problem exists. So how do you build confidence that this is actually something you can trust? And what we see today, this is not an aspirational story I'm giving, is that when the AI does the analysis of the prospect, it's just a lot more believable than when the proponent is saying, trust me, Mrs. Financier, everything will be okay in 10 years' time. Well, that doesn't happen very often.
Thank you.
Can I add some?
Please, yes,
so I have
absolutely.
some constructive comments. So I totally agree. But besides that, using this capability, we also can not only estimate the most probable outcome or get a recommendation from AI, but also we can estimate kind of uncertainty. Actually, currently in financial organizations, they are trying the following approach. They imitate people or cohorts, groups of people using some language model, some generative model. So generative model imitates actions, financial actions or other actions, and then overall they can see how the whole financial system behaves, right? In the same way, we can imitate the decisions by managers using generative models in the process of decision making and estimate the uncertainty, how it propagates through different decisions and different steps of the whole construction process and maintenance process, and we'll see how the risk is distributed in 10 years' time, for example. So this gives us a capability not only just to automate something, but also to control, because we should be able to propagate uncertainty through the whole process using these AI capabilities.
Thank you. Yes, please.
Yeah, I'd like to add something. I think the commercial management on a project is all about how well you're managing your risks. How early are you identifying? Do you have the right measures to mitigate? And it's all about that. So we have our pilots in AI is all about using AI for early detection of risks, whether it's scheduled performance, are there conflicts, bottlenecks, so the AI in a pilot program is able to tell us way in advance. Supply chain, someone talked about supply chain. We are using a tool now, AI-driven, that can look and identify supply chain risks, not just at tier 1, but their sub-suppliers, whatever number of tiers that it goes down to. Construction, the sequence optimization. There's always going to be on a construction site, you're going to have to rethink, reschedule, because your material may not be available, or the crew that's supposed to take the lead is not at the site. With an AI system that knows what is available there, quickly able to give you what is the sequence you need to work today. What are your work activities for today, which may be different than the one that you planned yesterday. I think there's some low-hanging fruit like, document intelligence, analyzing, validating drawings. But to the extent we can master using AI, detecting early detection of risk, and probably the next evolution of AI, we don't have it today, is to give you advice on mitigating measures. You have this risk, you can do A, B, C, D. If you do this and that, if you get that full analysis, then you're aiding the project manager, the field engineer, with the right information to make timely and efficient decisions.
Thank you.
That does exist right now. So.
Yeah.
For example, for technical equipment, that's true. If you have, say, turbine and you collected a database of different failures and how those failures were fixed in the past. So for a new failure, you describe what happens, you provide signals to the system, and it finds the most probable reason. So to some extent, it works and helps engineers. In this respect, though, this thing proposed by colleagues should work as well. You just need to collect enough data.
The data. So we're talking, I think, quite specifically about new build and expansion in already large established nuclear power programs at the moment. But let's think a minute for the newcomers in the field. And we know that there are over 30 countries considering or already building nuclear power. Do you think that AI might sort of create a level playing field for some countries to sort of negotiate these large NPP contracts for the first time? Does anyone maybe have some thoughts on new entrants to the nuclear space and how AI might help them optimize their project management, starting from this contract negotiations? Yeah, Deb?
We are in the middle of several contract negotiations for very large nuclear power plants with different countries, entities. It's not there yet, because you need to have really good set of data for similar projects before you can tap into AI, and the attributes of the data, the quality of the data is paramount. Everything we do when we convert it to fully digital is to ensure our data collection, our data set is so sound. As we build more and more projects, AI has a very solid basis to learn from. But I am not seeing with either the customer group or on our side in contract negotiations. I mean, you can use AI. There are tools that you can say, look for these words or look for these phrases. Tell me if there is some liability that is being created somewhere else in the contract. Those are easier to do, but not a holistic, tell me what you think about this contract, whether it's a good match for the project and for us. That I have not seen.
Do you share that view? Or?
No, I don't share the view. We have examples of countries that, I'm going to use the words, don't have the baggage that the legacy players would have, right? The well-established entities. If anything, I see that the well-established entities would say, well, we've always done it this way, therefore we continue to do it this way. And that, if anything, is probably the bigger risk. The newer entrants, where they're coming in and saying, we don't have the expertise, we don't have the skilled force, we don't have the reputation, we don't have the experience, are coming in from a place where we just need help. We want to move and we need help. We can't exactly, click our fingers and get thousands and thousands of people in our country to do this. So what we see is this much greater flexibility for these organizations to adopt new ways of working where, for example, I will give you a practical example here. There's a country in Asia that is deploying a large, they're prospecting to build a new nuclear station there. And part of the process is that they're trying to evaluate to what extent can we use existing facilities. There's decisions to occur as part of the negotiation to figure out how do we actually execute here. They're using AI to assess the scenarios upon which they will execute their scope, right? They say scenario A is we do this, scenario B we do this, scenario C we do this. And ordinarily that would be done with the expertise in the room, and you would say this is the best possible decision we can take. And instead they're saying, instead of doing that, let's use AI to do it. And further, they will then use AI to negotiate with the supply chain, where the supply chain issues the contract, as I said earlier, with some strategic misrepresentation because they believe the client is not experienced and not informed. And instead, the client turns around with the use of this technology and says, well, we can criticize every single bit of what you're saying using data from all around the world on how these projects perform. And here's some very detailed, very specific feedback that, frankly, the supply chain wouldn't have expected to have arrived from a quote-unquote immature organization, suddenly empowered with AI.
Yeah, well, thank you both for sharing your thoughts. Yes.
Well, some specific comment. Actually, when NPP is constructed in a new country, I would say, then it should be somehow integrated in its electrical system, right?
Mm-hmm.
And so what is also important is that based on AI, they can construct a digital twin of the electrical system, at least approximately, to see how this additional NPP, this additional source of electricity will be integrated so that they can really efficiently redistribute the energy across the whole system. This is also important thing. And of course, I agree that AI-supported information systems can help such governments to negotiate better because, okay, if we are not experienced, they don't have enough experts, they can at least find the relevant information better, right?
Mm-hmm. Okay. Yes, please, Dimitri.
Yeah, one more thing. Well, I think it doesn't matter how much information or data sets or so on you have in your company, because, well, personally, up to now, AI, for most of engineers and management, AI is a black box which makes some kind of decisions. Who knows what is it? Yeah, and we must implement. Well, I think must implement principles of explainable AI. We should to know what is that, how it calculates, which data based on. For MPP as a safety critical systems and ensure cybersecurity of model data. And well, I think it's kind of verification and validation for software is quite the similar thing. And well, I think the key measure to bring the contemporary gap between what AI can be done for us, between what based on some kind of information, data sets, and so on. And after that, after we thinking everything about it, we can be implementation to new NPP and some projects.
Mm-hmm. Thank you. Okay, this is very interesting, and I want to make sure that we have a little bit of a chance to talk about the future. We've been talking about where we are now. So looking ahead, and maybe I can start with you, Mr. Kanchwo. How do you see AI reshaping project delivery models for nuclear power plants in particular?
So I think the NPP's construction progress and the completion will be reshaped, and both. And firstly, they are digital. They are digital, not AI. For example, maybe the digital platform will display the weakness of the project management of the construction period, and then the project manager will discover it. But why this weakness happened? So the AI will deep thinking to tell us why is the reason. So, and then to make the project manager to be more strategic, and then the completion delivery maybe from best document to the digital, to the progressive digital, and the operators and the regulators will obtain the data from the digital twins, at any time in the construction period. So I think it's the change.
Okay, thank you, thank you. Yes, please, Dev.
I want to go into, like, you asked about future delivery models, right? At nPlan, we use data to tell the organizations we work with how long we think the project will take, what could go wrong with it, and what they can do to improve it. Now, the question we sometimes get is, how do I trust what you are saying? You are claiming my project will take this long. How do I know now, present moment, what you are saying about the future, to the point about trust? How can I trust you? And the answer is, let's not wait, right? You can't wait for 12 years to have the answer. So we went back into our world and said, well, we can show you a statistical proof that when backtesting these systems, it is 10 times more reliable than a human being attempting the same task. Most people don't care about technical, statistical tests. So instead, we came to the table and said, I'm willing to pay you if I'm wrong. If I'm wrong, I pay you. And to go further than that, this is now saying an AI company is willing to put money on the line, real capital on the line, that sits behind the insights that the AI system is generating, which means we trust the AI system so much we're willing to put capital behind it. In other words, this is moving towards a place where we will see, and we are actively working on it this minute at nPlan, we're building the first project overrun insurance policy on an all-peril basis. So what that means is, irrespective of the cause of delay, we will cover the additional cost it would incur to execute said project. Now, I'm not going to go into the details of how difficult it is to create such an insurance product, but the delivery model is changing. It means you have a new party entering a commercial and financial relationship with all other parties that has never been possible until now. At what point did we ever have a party that could say, AI has done the analysis and I'm betting the AI, with the AI, that this is a financial success, right? And you price the risk, because that's how insurance works. You're pricing risk through information arbitrage. And what this does, the impact, the result of a new party, if you want to call it that, is that you see the financiers that were on the fence, the ones that were like, I don't know if I can trust this organization to deliver these SMRs, all of a sudden becomes a lot more welcoming into financing the project, because frankly, someone else has taken the risk first, right? Mm-hmm. We all play a game of who's got the guts, perhaps, to go first, whether it's the expectation of a state nation to fund it or private financiers to co-fund it. The go first move is the hardest move. And what we're seeing now and actively building towards is this new commercial model that actually changes the entire financing dynamic that we currently see plaguing our industry today. It is so difficult to finance these projects, right? That's why it's hard. And we don't get enough done because the financing is so complex.
Mm-hmm. No, I think those are really interesting. But sorry, did you want
This resembles me a little bit the following thing. You can sell not a turbine, but thanks to telemetry and predictive maintenance capabilities based on machine learning, you can sell the time when turbine works correctly, right? So here you're selling not the management of construction processes. You kind of because of AI capability, you can if there are delays, you can provide money to the customer because of the delays. You pay for it, right? So you sell, in some sense, the construction time which is not delayed. Mm-hmm. Okay, maybe.
Okay, from our perspective, we're a builder. You know, our goal is, you know, given the demand from AI data centers, you know, the executive's order in the US, declaring nuclear energy as a national asset and all these incentives, there's going to be a significant boost in nuclear builds in the US. It's coming. We want to be able to execute these projects with half the people that we typically put, more affordable, and much faster. We created the backbone, the digital delivery, and it's working, and it's already giving us significant benefits. Our next step through these pilots is to start integrating AI agents in the tools that we already have. How we manage pipe installation, how we pull electrical cable. These are all digital tools. Now we want to benefit the AI intelligence in helping us, creating schedules for the crews, optimizing the schedule at any given point. So we can then double our capacity in a way and do more of the work that is coming our way. Mm-hmm. And I think if we can achieve it, you're probably not going to need a cost overrun insurance because there will be more predictability for the execution and confidence. The challenge in my mind is some validation of the AI systems. Like when we set up our digital delivery per NRC, we had to certify doing a bunch of tests under our NQA1 program. It's a requirement. You can't just use digital without that certification. I don't know, maybe there was a discussion yesterday or earlier today. The regulators will most likely ask a similar certification of AI to what standards, safety, security, are they in compliance with?
Well, thank you for that. And we have been talking about certification, harmonization, standardization, the basics, what would be needed. I'll give you the floor, Dimitri. And I just also want to open up the question about partnerships in this space. And maybe you have some thoughts on what role partnerships might play in accelerating AI deployment for these large projects. And again, you mentioned new parties. There's the technology. There are the international organizations. So what role might partnerships also play as we're looking to the future? But Dimitri, I want to give you the chance to...
Yeah, thanks. Well, I think that partnership is absolutely essential for the responsible and rapid adoption of AI into company. The key rule here belongs to regulators such as Rosatom in Russia or IAEA here. We need to jointly develop some kind of roadmaps and adopt regulatory frameworks with industry, vendors, and technical companies, I think. And with technical partners, they can bring expertise in data science and as well as, I think, in agile management, which may be working with traditional engineering companies. Well, we will be transformed into data-driven and data decision companies instead of traditional management, I think. About operators and engineering, we provide critical, important domain knowledge because all knowledge situated state in company, but not in vendors and so on. So we should to change quality data and risk knowledge into all community and share for each other. So I think it's sharing information is based on partnership between each of participants. I think.
Kancho, I'll come back to you in a minute, but I'd like to hear perhaps on partnerships and the future. What are your thoughts?
So I think particularly in China, just in China, I think the technical or application provider should be open their technique to all the conductors of the project, operators and regulators, and to make them use the same platform, use the same tool, and to meet their personalized requirement. And the more they use it, the more they use it, the more they understand it, and the more they understand us. So it is the realized time to make a unify of the AI awareness. Yes.
Thank you.
Well, I just want to mention one of challenges related to partnerships. So yesterday it was a very nice presentation of a colleague from Google. He mentioned that Google got data from Westinghouse, right? And I can hardly imagine how if a company responsible for nPP's development and construction is at least partially government owned, I can hardly imagine how the data from that company goes to some commercial company which is working in AI domain. So it's a big challenge how to do this, unfortunately, and not only for Russia, but for some other countries as well. And I guess we really need somehow to deal with this. Another challenge is information security, because even now many of information security officers, they don't adopt anyhow language models. They think that, okay, if it is inside the system, then can make harm. It has some special abilities, writing a code, who knows what it will do. So these are all the challenges we should definitely somehow to fight with. Otherwise, the development of AI will be kind of prohibited for the next several years, for sure.
No, thank you. And I think we're seeing different models, we're seeing different approaches, shared challenges, but different approaches. So, okay, I think that we can maybe move on to our observation part of the panel. Deb, may I perhaps start with you, and we'll come down here to Evgeny and then come back to you on the recommendations. But if we can kick off with an observation that you have from the discussion today, the symposium overall, but it would be helpful if it were on, specifically on the project management side of things, conversations we've been having.
Overall, across this conference, across many conferences that are happening all around the world, talking about project management and AI beyond even the nuclear sector, what is abundantly clear, including by many of the opinions shared by each panel member, and hopefully in what I've communicated so far, is that we're not just talking about rounding errors here. We're not talking about a 1% efficiency, saving someone 5 hours a week and leads to nothing. As Ahmed said, getting to half the size of the project team to execute with double the amount of certainty, so you don't need to buy this insurance product, yes? These are quantum shifts. These are monumental shifts in what is possible in the world today. And yes, AI has been around for a little while, but no, it has not been capable of what it has not been possible to do what we are talking about on this panel until now. And the observation, observation towards recommendation I would move towards is the reality is that despite talking about evidence of it working and promise, the two are working together here, we still, on average, see most investments, most projects invest less than 0.1% of the CapEx, of their available CapEx, into the technology that will power them to make a 50, 60% difference in the outcome that they could stand in front of them. If you ask anyone that chooses to make a bet, right, if you play the game of bets, that's an unfair bet. That's just a bet that is unlikely to go very far. And connecting to your question on partnerships, the partner that is capable of changing this landscape are the technology companies, if it's not so forward for me to say for myself, right? How do we become part of the top table where there is real investment and real accountability to delivering the change? Of course, you can't just have the responsibility without the accountability, to my point on insurance. So we're not just at the dawn of a new era, right? The era's already started. There's more than enough case studies. If you want specific examples, come meet me afterwards. I'll spill them all out at you in the coffee break. But the thing that's still missing is that we still don't see enough investment on each project, and we still don't see the role of technology as a strategic lever. It's a tactical lever left down in the 0.1% of capital available, right? And that is misaligned, in my opinion.
Yeah. Thank you so much.
You're
going to get your observation, so hold on to it tight. Ahmed, can I move to you?
Yeah, I think there's some interesting initiatives across the board. You know, what I've learned from Dev and others. You know, forums like these are good to get a high-level understanding. You know, maybe there's another level of collaboration organized by IAEA that goes down a couple of levels, because we're talking at 50,000-foot level. You know, devil is always in the details, what works, how it works. So that would be an interesting forum if IAEA takes the lead to organize more exchanges to understand. So that's one. The second is maybe a separate session on, you know, how do you regulate AI in nuclear construction? You know, what standards? Who's going to set the standards? Is that going to be the regulators in each country, or is that going to be spearheaded by IAEA? How do you do the testing and the validation of the AI agents that we will start using in various phases, functions within building a plant? I think there will be more concern when you're designing nuclear safety-related systems than installing, you know, construction, optimization, and planning. They're different buckets. Yeah, I'll leave it at that.
Thank you. Okay. An observation, please.
Yes, my observation. I think the development of AI technology in NPP's construction should be encouraged and should be patient also. So do not abandon it for its initially unsatisfaction, and do not expect them to do everything either. So continuously to push it, and maybe one day we will get a lot.
Thank you. Concise and clear. Thank you. Dimitri.
So just one more thing. Well, I think that, well, up to now, AI is a black box. And if you want to apply AI into your company, into your project, complex project like MPP construction and maintenance, you should to believe that data which you obtained based on AI algorithms, you should to confident it. So the confidence is based, well, I think is based on transparency, and I should to believe that decision making by AI system is true. Well, I think that if I not believe it, I do not use AI system. So first of all, I think that management should be to believe AI, to believe that it is real assistant, like a human assistant, as well as, well, based on historical data, it can generate new, correct, accuracy, new data. So I think this is main mainstone of AI. We should to believe this system.
Okay, thank you. So, turning back to you, Evgeny, an observation, and then if you would like to kick off the round of recommendations, we will head back down the panel. And I know they tend to get a bit mixed.
The recommendation is to be patient, of course.
Okay.
And let me explain why. So, again, the very first speaker, he told that we are currently at tactical level, but not strategic level. And actually, this is true, because often on a middle management level, people just find some use case, apply some AI model, get some 1%, 2% increase in efficiency, and that's it. But if we consider the whole business process where this automated step is inside, then on the level of the whole business process, this 2% of efficiency decreases to 0.00% of efficiency for the whole business process. So in many cases, because of that, the only possibility to demonstrate real efficiency from AI automation and autonomization is when only you construct the whole business process from scratch like AI native process. And this requires usually a lot of additional efforts. You should maybe redesign your organization partially. You should possibly invest a lot. And not everybody is ready for that. That is why I told you should be patient. The second thing is, however, in order to survive in this race, the only possibility, taking into account that stakeholders are not ready to invest a lot, is to try to find such places in the whole organization where incorporation AI can really provide you not 1-2%, but maybe at least 10-20%. And then you will demonstrate that it improves, and you will be able to rebuild the system step by step, at least partially. And from my point of view, this all, to some extent, this resembles the situation with internet in 2000. Although the crisis of dot-coms happened, still those investments were really important on the scale of 5-10 years, because nowadays we cannot imagine our life without internet. So with AI, the situation could be the same, and I'm sure it will be the same. And so for such organizations as companies constructing nuclear power plants, they should survive in the sense that they should always try to find where this can be integrated, and then at some point they will be winners of this process.
Okay, thank you. Dimitri, can I ask you? No more recommendations. Yeah, okay, perfect. Yes, I think we've captured. Kantro, do you have something to add in terms of a recommendation?
Yes, recommendation. I think it's about the standardized. Yes, I agree. We need a framework. We need a framework of the AI technology application development, and maybe including some data standard, maybe some agreement of the application. So maybe IAEA can do something about that. Maybe to organize some more conference or workshop, and to involve every country to contribute.
Okay. Thank you very much. Ahmed, do you have a recommendation?
The only thing I'll add, because I think this patience is a good advice. You know, this is a journey, and you have aspirational targets. Ours is to see if we can have the workforce. When that happens, who knows? But along this journey, I think we should always be cognizant what is our investment and what return we're getting. So it could quickly, depending on how technologies are evolving, a diminishing return. So every company, I'm sure, would look at it the same way. Am I getting the results? Am I getting the return from use of AI?
Thank you.
I actually just want to reinforce a recommendation Ahmed made. which is around the IAEA convening power. My take, when I speak to whether it's builders or developers of nuclear power stations around the world, and of course I'm going to them with an advocacy of use AI at a strategic level to make a quantum shift in your development, is this sense of nervousness. They're naturally nervous. They're like, I don't understand it. How can I trust it? They're just nervous. Leave it at that. And the hardest thing for me to do as an individual or as an organization or a corporation is to communicate in an impartial way. I'm, of course, biased, right? I'm biased towards the progression of AI. And what is missing in the world is this convening force or this forum, one level below the level that is in this room right now, but in the project management discipline for nuclear power stations, where the 2 or 3 brave souls that have already gone through the change, that are seeing the results, are able to share inside a forum with those that are feeling nervous, right? And it's nearly impossible to do this on a call it like a global arena and just broadcast it on large media outlets and just shout to the whole world about project management in AI, because most of the world doesn't really care about it. There's only a good 100 people on the planet that really need to know about it, that really care about it, are very scared, and really need help from their peers. I'm not talking about senior people giving top-down directions. I'm also not talking about some sort of directive that would come. I know the IAEA does not issue directives, but it would be a peer-level convening force that allows these stories to be shared. Even today, Ahmed learned something new about what AI is even capable of, right? That was how do we scale that? How do we do that in a more systematic way? That would be my recommendation, building on Ahmed's.
Thank you so much, and I think that that's a really important point, and sort of the spirit of this symposium was really to tackle some of these questions at a high strategic level. That was the objective of this symposium. But what we're seeing is the need for more technical, in-depth conversations and exchanges, as you say, at the peer working level, in the different disciplines. So here we're talking about project management. Yesterday we were talking about perhaps more regulation. So I think that this is an interesting perspective to have, and forward-looking vision to have for all of us collectively. So thank you for sharing that.
And I hope that this event will be a platform for such exchanges.
I hope so too. Dimitri, you wanted to...
Yeah, I would mention one more recommendation. Do not afraid, try to implement AI into your routine and company. So let's try to do some very similar project, some kind of pilot projects and so on. You choose very first positive results. It could be increase your own think mind about, AI is a very good instrument to improve your own quality of management, quality of data you researched, and so on. So let's try it. It's true that AI is a journey, a scientific journey and management journey. By altogether, I think we try to move through this path, and altogether we choose very significant results. Yeah.
Thank you. I think those are very nice concluding words for this panel. So I would like to thank you for that, Dimitri. And I would like to thank all of you, all the panelists, for sharing these valuable perspectives. I think it was a very rich conversation, and we went into quite some detail. Well, I won't say detail. I think we heard some nice examples, kind of highlighting what the conversation is around construction and long-term operation of the existing fleet, perhaps new build in countries that are just starting out. So thank you for joining me in this conversation on the role of AI in all of this. And it makes it clear that AI is no longer a distant concept, right? It's here. and it's already shaping how we plan and how we execute and manage these large capital projects, including in the nuclear sector. So we had a little bit of a chance to talk about some other sectors, but beyond the efficiency gains, we talked about cost, we talked about time. We've also heard how AI can anticipate some of the risks and help us improve decision-making. Again, not replace decision-making from humans, but improve it and enable more resilient delivery models, perhaps. So, so the challenge now, I think, is how to scale some of these successes responsibly, as we've been talking about, and ensuring that the innovation is really paired with the robust governance that we need, and the collaboration across the industry and regulators, international organizations, and perhaps newcomers and new stakeholders to this space. So with that, we conclude panel 4. Please join me in thanking our panelists. Thank you.